Okay, let's start with some SN1, SN2 practice here. Okay, we're not going to decide right now between just substitution and elimination, only between SN1 and SN2. Next video, we're only going to do between E1 and E2. Okay, we're not, we don't need to start doing that right now. We have time. We'll learn that steps gradually, not throw too much all of you at once. Okay, so I have some example problems up here. Again, it's only between deciding right now SN1, SN2. Some of these can do elimination reactions, yes. Okay. We'll do that maybe later in the week. We could use the same problems and we can build on that. Right now, just SN1, SN2. Before I get to these real quick, I forgot again at the end of the last video, talked about with SN1, SN2, we know that if we have a primary group, it's going to be SN2, and if we have a tertiary group, it's going to be SN1. Secondary, it could be either, okay? Also, allyl and benzyl substituents, it can be either, okay? It can be either. Allyl, if you remember, is in this position, so there's some resonance there. This is not primary, this is allyl. It's one away from an alkene, okay? So this, if we see a structure like this, or we see something in the benzylic position, it can also participate in resonance, okay? That will also be, like this isn't quite secondary, it's benzyl, but benzyl and allyl, okay, are gonna also be kind of like, okay, we can do SN1 or SN2. Okay. Now, let's get into these examples. Again, this is basically like a true or false. You have a 50-50 shot. It's either SN1 or SN2. Going over those rules in the last video, go ahead and try these on your own. Pause the video, try them. If you don't feel confident, go ahead and go rewatch or watch that video if you haven't already. Welcome back. Okay, let's do this. Here, let's go through. Notice what do we have here? I see we have a secondary halide, okay? And I also notice that chlorine's a pretty good leaving group, okay? Secondary, pretty good leaving group. Cyanide. Cyanide, if you remember, is a very strong nucleophile. Pretty much the strongest there is, or one of the strongest nucleophiles, okay? That's going to show up a lot. Cyanide is a very strong nucleophile. And I also have an aprotic solvent. All of those things are telling me SN2. So if you guess SN2, you are correct, okay? Our product here would be cyanide bonding where chlorine is, and we would reverse that stereochemistry because of backside attack. Okay, SN2 for the first one. This next one, same thing. I have a secondary halide, I have chlorine. All right, cool. Now, in terms of nucleophile, OH minus, I have that negative charge, very good indication that I have a strong nucleophile, and that's the case here, okay? So I'm thinking SN2. I have a polar protic solvent. I have a polar protic solvent that's going to interfere with this OH, and I'm going to make more water because of it. It's going to interfere with my base. It's not going to be as effective. This one is more likely to be SN1, okay? Despite having a very strong nucleophile, that nucleophile is going to be hindered because of my polar protic solvent, okay? Again, chlorine. It's going to be my leaving group here. Let's look at my nucleophile. Explicit negative charge there on sulfur. It's a pretty strong nucleophile, okay? But also notice I have a polar protic solvent in my methanol group there that's going to interfere with my nucleophile, okay? And because of that, this one is more likely to be, that's why this hydrogen's here. Almost got caught up there, okay? Now, if you notice, this is not a secondary chlorine. Tricky. This is actually a primary chlorine. This hydrogen drawn in here is just to confuse us, I guess. I didn't even notice that before. I mean, yes, I did. So this chlorine is primary, okay? It's primary. I do have a pretty strong nucleophile, so despite having a polar protic solvent, I'm still going to say this one is going to be SN2. This is a trickier one, but primary chlorine, we're going to have enough there. I think this one should be SN2. Okay. Originally, because I thought this was secondary and I had a polar product, I would have said SN1. Now that I see that this is primary, however, SN2. Okay. On that note, let's go down here. Right away, I see I have a tertiary halide. That's going to tell me SN1. I can get a pretty stable carbocation intermediate, despite the strong nucleophile, despite the polar A product solvent. That's all telling me SN2, 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 SN1. It's tertiary. We're going to get a carbocation intermediate, rate determining step, more stable, and so on. Let's go ahead and go up here. Okay. I have a strong nucleophile, negative charge there on my ethoxide, okay? Also, would favor SN2 as a polar A product solvent. So that's good, okay? Thinking SN2, but I don't really have a good leaving group. Don't have a good leaving group, and there's not really any hydrogens here that I can really make this a good leaving group, make it water. Because I have a poor leaving group, I think this one's going to favor SN2, okay? I guess it would anyway with the strong nucleophile and product solvent there. But because we have a poor leaving group, that's again one of our cases. This one's maybe so poor that I would maybe even think this is no reaction. But I said only SN1 or SN2 in the directions, okay? So if we're following the directions and we had to choose one, this would be SN2, if anything, okay? I could have probably chosen a more appropriate leaving group than alcohol. Maybe something like, maybe like an amino group possibly. But this was just demonstrating that I have a poor leaving group, and if we have a very poor leaving group, it's going to favor SN2, okay? Our next example here, I see I have a good leaving group with bromine in a secondary position. I have a strong nucleophile, so this is going to favor SN2, polar product solvent, however, SN1. These two are going to interfere with each other. It's going to slow my rate down. It's going to be better if I just have SN1 and get a carbocation in there, intermediate. Okay. All right. I have water in this example as both my solvent and my nucleophile. Weak nucleophile, very weak nucleophile. So this is going to tell me SN1. But my primary chlorine, not primary chlorine, it's an allyl chlorine, notice, okay? It's one carbon away from my double bond here. So that's not really going to tell me, my primary is not going to tell me, oh, SN2. It's going to be SN1 or SN2. Let's look at water again. We know water is a weak nucleophile. It's also a polar product solvent. So this one as well is going to be SN1. Be careful. This is not primary chlorine. This is allyl chlorine. Our last example here. Secondary again with chlorine. Really like chlorine. Okay. All right. And I have an explicit negative charge on my alkyne, okay? This is pretty much the strongest nucleophile there is, along with cyanide, I believe. Really, really strong nucleophile. I don't even have the solvent drawn in, not all of them will, so we can just say that this is SN2, okay? All right, hopefully that helped kind of go through the rules of SN1 and SN2. We're going to do E1 and E2 in the next video, and you guys should be in pretty good shape for class on Monday. All right.